solving equations with multiple exponentials. So if you compare number 7 to number 1, or any of these 1, 2, 3, notice there's only one time where the x is in an exponent. These, it's on both sides of the equal sign. In order for these problems to work, you have to have a common base. So like number 7 would work right away without any extra work right off the bat, because they both have a base of 2. Now before we get into some of these problems, there are some things that you need to remember. We can rewrite numbers. I can rewrite 8 as 2 to some power. What power would that be? 3. Yep. I can rewrite 16 as 4 to the second, or as 2 to the fourth. 2 to the fourth. 2, 4, 8, 16. Yeah. 2, 4, 8, 16. Okay. What about 1/4? Yes, -1. So 4 to the -1 power. Because this would 1 over 2 squared, which is 1 over 4. So this is kind of the process that you're going to have to do up front if you don't have a common base. Now number 7 does have a common base. So whenever you have a common base, all you got to do is set these two equal to each other. 1 equals 2x and solve for x. So this would be 3x equals 8. So x equals 8/3. Not bad. Now number 8, I have a base of 8 and a base of 2. I need them to both be written with the same base. So how could I change this 8 to have a base of 2? How could I rewrite it as, I want to rewrite it as 2 to some power. 2 to what power is 8? The third. So what I'm going to do is rewrite this right here as 2 to the third power, and then I still have that 3x minus 2. It's hard to open. Alright. Okay. So all I did was change the 8 to 2 to the third. And now I have this common base. Remember exponent rules. When you have an exponent to an exponent, what do you do with those? Multiply them. So what I'm going to be doing is, when I set these equal to each other, this is really going to be like 3 times 3x minus 2 equals x plus 5. So I'm going to have to distribute that 3. So this would be 9x minus 6 equals x plus 5. So 8x equals 11. Or x is 11. Now this one I only had to change the 8. Sometimes you might have to change both of them, and sometimes there's more than one way you could change it. And you still get the right answer in the end. So let's look at number 9. I have a base of 9 and a base of 27. I can't just, like the 9, I can't turn that into 27. What could I make a common base of? 3. This 9 is 3 to what power? Yep. So I can rewrite the 9 as 3 squared. And then I still have that 2x. 3 to what power is 27? 3 to the third. 3 times 3 is 9, times 3 is 27. So I took out the 9, replaced it with a 3 squared, because 3 squared is 9. I took out the 27, replaced it with a 3 cubed, because 3 cubed is 27. Now I'm going to do 2 times 2x equals 3 times x plus 2. And I got x equals 6. Now this, I mean, some of these you could plug, like go back to your original and plug the x back in to see if it worked. But there's no way we're doing 9 to the 12th power in our head. So you might just hope you did it right, because you probably would not have a calculator on something like this. Number 10, and this one you could kind of go a couple different ways. We have one base of 1/2, and one of them has a base of 4. You could do it, you could change one of them, or you could change both of them. Tell you what comes to what I would, like if I saw this, my first instinct would be like, this is 2 to the negative first power, and that's 2 squared. That's one option. Really, let's see. This, you could, I wouldn't do this. You can make this 4 to the negative 1/2 and leave that 4. I don't think I would do that. Yeah. I would do it like this. You're just trying to get a common base. So 2 to the negative first is 1 over 2. 2 to the negative second is 1 over 2 squared. 2 to the negative third is 1 over 2 cubed. And so we would have negative 1 times 5x plus 7 equals 2x. Negative 5x minus 7 equals 2x. Negative 1 equals x. Any questions? Now the last type of problem is the most complicated, just because there's some extra steps that you have to do. So if you have multiple logs, so the question that we did up here, you only saw a log one time. But if you have multiple logs, there's a little bit more work to it. You're either going to get it to where a log is equal to a number or a log is equal to a log. And we're going to condense logs to do that. So notice how number 11, I don't have any just numbers by themselves like I do in, really 14 is the only other one. So these I want to get log equals log. So this left side, I need to condense these into one log. And so this is going to become log of what? It's got a plus sign. It'd be 3 times. Yep. So 3 times x plus 4 equals log 5x minus 2. Which is, go ahead and rewrite that as 3x plus 12 equals log 5x minus 2. So when you have log equals log, you take, as long as the base is the same, these are both log base 10, you set these equal to each other. Kind of like you did in the last couple problems, we just set those equal. But there's an extra step, and I'm going to run out of room. Equals 5x minus 2. Leave some space. So 14 equals 2x. 7 equals x. We got x equals 7. That could be our answer or it could not be. And we have to check for what's called extraneous solutions. So these are solutions that we get when we do the math, but really they don't work. Because sometimes when you condense logs, like some things are lost in the mix. You cannot take the log of a negative number or the log of 0. So what I'm going to do is I'm going to take this 7 and put it back in your original problem, either one of those, and see if I plugged a 7 in, would I get a 0 or would I get a negative? If you do, that means you don't count it. It would be no solution. If you don't, if you get a positive number, it's good. That's your solution. Okay, so we have to check to see if it's extraneous. So if you go back to your, now log of 3, there's no way to put in x. But if I do 7 plus 4, I get 11. That's positive. So far it's good. 5 times 7 is 35. Minus 2 is 33. That's good. So that means that my answer is 7. I could imagine that on a multiple choice test, let's say you got an x value that truly didn't work. That x value would be on there along with no solution. So you have to check. You have to be careful. What we saw earlier, none of those, I guess technically we should check them. I don't know that because you're not actually condensing logs, I don't know that it would ever come up that there would be an extraneous. But these for sure could be. All right. So first of all, let's condense this side. This would be natural log of x plus 1 over 3x minus 5 equals natural log of 7. Might have to do some extra work on the back. I should have spaced these out more. And so now these are they're both natural log, same base. So I'm going to set x plus 1 over 3x minus 5 equal to 7. What would you do to solve this? You would what? You would multiply. Normally, like what I have students do is make this 7 over 1, and I say cross multiply because they're used to that. So when you multiply x plus 1 times 1, you get x plus 1 equals, and then we're going to multiply the 3x minus 5 by 7. That's going to give us 21x minus 35. You're distributing that 7. So this would be, if I add the 35, I'm going to get 36 equals 20x. So x is going to be 26 or 36 over 20, which, let's see, if I divided by 4, I would get 9 over 5. That's a positive number. If I add 1 to it, you don't really have to know what that value is. You just need to know that it's positive. You add 1 to a positive number, it's going to be positive. This one is a little harder to figure out without a calculator. So if you take 9/5 times 3, that's going to be like 27/5. Minus, if I want to give this one a denominator of 5, it's going to be 25 over 5. So, like, is that going to give me a positive number? Yeah. Number 13. Let's condense these, and we get log base 3 of, what am I going to do with those two things? The x plus 2 and the x minus 3. Multiply them. Yep. So it is not x squared minus 6. Don't put that down. You have to do FOIL method. X plus 2, x minus 3. X times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. 2 times negative 3 is negative 6. So when you're multiplying x plus 2 and x minus 3, you get x squared minus 1x minus 6. Equals log base 3 of 14. So now I can set x squared minus 1x minus 6 equal to 14. Now solving this for x, it's going to be back like we did in Algebra 2. You've got to get it, when you have an x squared, you have to get it set equal to 0 first, and then you're going to factor it. So I need to subtract 14 from both sides. We get x squared minus 1x minus 20 equals 0. And then I'm going to factor that. So I need two numbers that multiply to be negative 20 and add to be negative 1. Negative 5 and 4. So this factors into x minus 5, x plus 4 equals 0. Okay. And so that means I have x equals 5 and I have x equals negative 4. So sometimes you could potentially have more than one answer, but I'm going to go back and look at my original parentheses and see if I can plug both of those in and get a positive. So if I plug in a 5 there, I'm good, positive. If I plug in a 5 for the x minus 3, I'm good. So that one works. What about negative 4? It's not going to work in either one because negative 4 plus 2 is still a negative. Okay, so that one is a no. So this one, only one answer will truly work in that. X equals 5. And all those quadratic ones, it's like you're just learning the process, and then I throw in old stuff like factoring. All right, 14. This one is the only one of any of these that have a plain number, so we're going to get it to a log equals a number. So I'm going to condense this side right here. This one is going to be a lot easier. It's going to be natural log of what? X over 3 equals 2, which is technically the same thing as log base e of x over 3 equals 2. Those are the same thing. Do you remember what I do to solve this for x from yesterday? Convert it. Do your swirl. So this is e to the second equals x over 3. And how am I going to get x by itself? Multiply by 3. E squared is a decimal. You just leave it. So if I multiply both sides by 3, I get 3e squared equals x. All right, 15. It's going to be a log equals a log. So when I condense, I'm going to have log base 4 of x over 2 equals this quadratic, you're not.
You didn't do this one by yourself.
Yes. So that 3 that's in front of the log becomes an exponent up there. Did anybody else notice that? Did? Yeah, I did it. I will do this way. Because we've written exponent, but I will work out the incorrect way on the board. This one, we have x over 8 equals x plus 7. Make that a 1. So x equals 8x plus 56. It's still going to be negative 7x negative 8. So you would have lucked out on this one. Not if you mess that, it's going to be no solution either way, because negative 8, if I plug it in there or there, it's still going to give me a negative number, which is no solution. You won't always get lucky. Number 16, you may want to just work this one out on the back. I'm going to do that. It is log of x plus 5 minus log of x minus 3 equals log of x minus 4. So go ahead and start condensing and see how far you can get with the algebra. So if we multiply, let's multiply these first. X minus 4 times x minus 3. You have to do FOIL method. It's not x squared plus 12. If you do x squared plus 12, you're going to miss that middle term. Okay. X times x is x squared. X times negative 3 is negative 3x. Negative 4x plus 12. And so when I multiply these, I get x squared minus 7x plus 12 equals x plus 5. From here, you need to set it equal to 0 and factor. And I'm going to let you try that. We need two numbers that multiply to be 7, but add to be negative 8. Negative 7 and negative 1. So x minus 7, x minus 1 equals 0. And just as we did in Algebra 2, which is what I'm about to be teaching my Algebra 2 shortly, when you set each of these equal to 0, you get x equals 7, x equals 1. Now, if I plug a 7, positive, 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 this one's good. 1, positive, negative. 1 minus 3 is going to give me a negative. So 1 does not work. So the only solution would be 7. This was multiple choice. You would have 7 as an option. You would have 7 and 1 as an option. And you would have no solution as an option. So be careful. All right, we are done.